Hi everyone. In this video, you will get to know the basic idea behind Hole current. Firstly, we will assume that an electron in the valence band has absorbed energy sufficient enough for making its transition to conduction band. As you can see, the electron transition left a vacant position in valence band. This vacant position is nothing but a hole. Now we assume an external battery such that the positive terminal is on the right side and negative terminal on the left side, so that electrons will try to move in the right direction under the influence of electric field. Due to the electric field, the electron located just left to the hole will try to move in the specified direction as shown. The electron further ahead will move in similar manner, and this procedure will keep on repeating. As you can see clearly, even though numerous electrons are moving, it seems as if a single hole is moving, and for the same reason it is called Hole current. Putting it simply, Hole current is actually the movement of several electrons. So far as the flow of electric current is concerned, the hole behaves like a positive charge, equal in magnitude to the electronic charge. In an undoped or pure semiconductor, the number of holes is equal to the number of free electrons, as a hole is formed only when an electron transition takes place. Thermal agitation continues to produce new electron-hole pairs. On the other hand, electron-hole pairs continue to decrease as a result of recombination. Pure semiconductors have low conductivity, and the current generated is of no practical use. Therefore, extrinsic semiconductors or doped semiconductors are used. Suppose an external battery is connected to an intrinsic or pure semiconductor. Then electron current will be equal to hole current. This equation means that the hole current is equal to electron current not only in magnitude but also in direction. And the net current will be the sum of hole current and electronic current. Now, I have a simple question for you. In an intrinsic semiconductor, total number of holes are equal to total number of electrons. State whether the statement is true or false. The answer is false. Total number of electrons does not change. The number of free electrons changes with the change in hole number, but the total number of electrons remains constant.